what is the difference between this problem and this problem. I covered this one on Wednesday during the review. And I told you we have here something called poly. That's right. And we covered this idea many times before. Poly means the only thing we learned from poly, this force equal this force. That's it. Forget it. We have here poly. What does it mean? This force equal this force. So FAB equal FBC. Here, FBC equal FPE or BE. This one equal this one. Anybody can tell me what is the difference between the two problems right now? This one covered in the review session. This one was in the exam. I need to listen. Anybody, I need to answer. Anybody can tell me what is the difference between the two problems? Aaron, I need to, okay, forget it. I didn't mention anything regarding the spring. Okay, I'm coming. Wait, I'm coming. Don't worry. Until this moment, any difference between this one and this one? No, no difference. No difference. During the review, I told you what will happen if we have spring here. Do you remember? If you didn't, go back to the recorded meeting. Go back to the recorded meeting on Wednesday, I believe September 30. I told you, and also during the exam, if you have spring, forget it. If you have spring, forget it. That means I will forget we have spring here. I will assume this one like a cable, like rod. So what do you have at buoyancy? We are looking for particle equilibrium. Particle means 1 point. Particle equilibrium. I cannot do equilibrium at B because B is not a particle, it's a poly. So I will do particle equilibrium at C. I have vertical weight, which is 10 kip. I have horizontal force, which is spring. I forget it. So we have FCD. I have inclined force, which is FCB. I am done. I am done. Go ahead and apply summation f of x equals 0. What do you have in x-axis? We have FCD. We have negative FCB cosine 60 equals 0. I'm talking about this equilibrium. I'm talking about this point C. We have horizontal, we have vertical, we have inclined. That's it. Summation f of y equals 0. So FCB sine 60 minus 10 equals 0. I have two equations. I can solve them together to get FCB and to get FCD. Once you are done, don't forget FAB equal FBC from the poly. From this poly, this force equal this one. I am done. Anybody did this, he got 20 from 20. I didn't care about spring. I didn't care about spring. If you go back to the review, I told you, if you have a spring here, forget it. So at point E, we have horizontal force, we have vertical weight, we have inclined force. What is the difference between this one and this one? Anybody can answer me. Anybody can answer this question? What is the difference between this equilibrium or this situation and that situation? Everything is recorded. If you go back to the review session on Wednesday, September 30, I covered this one with spring. Any answer? Any answer? One more time. Any answer? No answer. You cannot answer. You cannot answer. It's your fault. Second problem. I'm sorry. This is the review. Can you watch this problem in the review? I covered it on September 30. The same problem. The same problem. So which problem is harder, this one or this one? You are kidding me if you say there is a difference between this one is the same like this one. What about this one? Question number 3. Oh my goodness. Can you watch? Problem number 3. The same problem. What is the difference between this one and this one? Anybody can tell me? Guys, are you listening? Are you listening to me? What is the difference between this problem in the real exam on October 2nd and that problem I covered on September 30 in the review session? This one, it's harder than this one. This one is very easy. You have a force in X. You have another force with all alpha, beta, gamma. And you have another force with 2 points. What is the coordinate here? What is the coordinate here? This one is more easy than this one. And if you would like to go back to your modules, you will find this problem covered before. Forget it about any spring. And during the exam, I told you, forget anything related to spring. Assume it like a normal force. Reactions. I'm not sure why student put reaction at B. I'm not sure. Many students put XB or YB. I'm not sure. Did the problem tell you that there is a support at B? We have pin support at A. So we have 2 reactions. We have roller support at C. So we have 1 reaction. What is the meaning of reaction at B? Who told you this? This type of problem, we need to read the problem carefully. You have two supports. One at A, what is the type? It's pin. One at C, what is the type? It's roller. So we have 2 reactions at A, 1 reaction at C. Go ahead and get your equivalent. Go ahead and apply summation f of x equals 0, summation f of y equals 0, summation moment at any point equals 0. What is the problem? So what do you mean by this exam is harder? I believe you think this exam is not like the exam from last year. Everybody was expected to open your notes and cheating. Everybody was expecting to see the same problems. So you are writing from your notes. This will not happen. This will not never happen. You have to think. You have to learn to answer your problems. So guys, what is the difference between the two problems, the two exams? Okay, I will assume we are like kids. So if we see something new, we will never solve it. Okay, this problem, and I told you during the review, we have a spring. So we can solve this one. It should be this one exactly the same like this one. This one exactly the same like this one. Can you write anything here? Can you write few sentences here? You cannot. You cannot write anything. You cannot watch anything you understand from this problem. Any few sentence. I didn't answer. I didn't ask for the final answer. Can you write few sentence? Can you write anything here? Why student get 20 from 100? Why some student get 40 from 100? Why some student get 0 from 100? Some student get 13 from 100. Why? I told you guys, the review session is very important. You think that the review session will give you the exam. No, I'm a different. This course is different. This instructor is different. You have to learn something to pass this exam. I have 7 students who got 100 from 100. I have to protect this student from other students. I have to be fair among the students. Students who are doing well, they must be doing well all the time. Got A. And students who don't, I'm sorry. The only way in this course to submit your assignment to do well during the exams, that means you understand, you learn something. Then you pass. At the first meeting in this course, I told you guys, this course to learn something and to improve your GPA. Anyway, this problem is quiz number, the quiz after the exam, so don't forget to submit this problem to consider it as a quiz. We have a new topic today. Theoretically, the previous material will not be considered in the coming exams, exam number 2 or exam number 3, theoretically. But in the real life, we will need some information from these modules in our expected modules. So starting from this one, exam number 2 will start. Starting from this module, we will expect problems in exam number 2. Our topic today is talking about truss analysis. This course, or this topic, I'm sorry, this topic is related mainly to bridge engineer. And this topic will be covered in more details in another course called Structure Analysis and Design for construction or for CONI student. What is the meaning of truss? Truss means a structure, type of structure. I believe you watched these types before during your driving, beside your home, anywhere. We have members, these members connected together. These members connected together. The final shape of this structure can be called truss. Can you watch this bridge? We have members. Most of the time, probably 90% made from steel. We can expect it made from wood sometimes, but mainly made from steel. So we have a steel member, another steel member, steel member, steel member. All of these members connected together here. This point can be called joint of connection. Finally, you can form this shape of structure, and this shape is rested here on abutment. This abutment in our course can be considered as supports. Probably your support is hinge, probably your support is roller, based on the type of support. So, did you got the idea for the new structure for today? It's truss. It's very easy and very interesting also. Any questions so far? Guys, do you have any questions so far? A few minutes, we will watch this video. Oops, just a second. I have a question. Can you hear the voice for the video? Okay, perfect. So guys, can you watch? We have steel members. These steel members connected together by something here called joint. Can you watch this joint? It looks like blades and bolts connected these members together. So after we are done of this bridge and connected all of these members together to form this shape, and we constructed the floor or the deck of the bridge, so watch what will happen. So can you watch this support? This is the hinge support. I'm talking about the real bridge, the real structure, the real truss. This is the real hinge. At this support on this side, we have hinge. On the other side, we have another hinge supporting your bridge. So guys, truss means members connected together. Most of the time they are still members connected together by something here called joint. The real life, or in the real life, these joints looks like blades, bolts connecting these members together. Then the whole structure is supporting from one side on a support and on the other side on another support. Your support probably hinge, roller, or sometimes fixed. So what do you think? Interesting. The link for the video is available in your PDF files. You can watch it later many times. Okay? So keep in your mind, truss means members connected together to form this structure. And finally, this structure is supported by supports. Here is the real joint. Can you watch this one? Here is a member. We have here a member. We have vertical member, another inclined member, this member, and this member. All of these members, how many? 5 members. All of them connected by this blade called gusset blade. This gusset blade is bolted to this member by these rivets or bolts sometimes. The gusset blade is connected by the vertical member by these rivets, and also connected here by these rivets, and connected by this member by these rivets. So finally, you can find all of these members connected together at this location or at this joint. So in the real life, your member is a real member. Looks like I-beam or channels or angles, steel. I'm talking about steel members. But in our course, we idealize this real structure to something looks like this. Can you watch? This member in the real life looks like this. But in our course, we will consider it looks like line. So this one called member. This one is a member. This one is a member. And this one is a member. All of these members connected here at joint called B. In the real life, your joint looks like this one, B. In our course, we will idealize this connection by this joint only. Any questions so far? So guys, so we are talking about real structure, which called truss. Your truss looks like members. These members connected together by joints, and the whole structure is supporting by supports. Your support looks like hinge or sometimes looks like roller. Any forces in this truss will be only at this joint. We will never see a load at the intermediate point of a member. Will not happen. All forces must be at these joints only. Only. So can you watch this floor or this roof? We have here something here called secondary beam, which called Berlin. This Berlin will support the floor or the roof. So if you are sitting here, your load will go to this sheet, and this sheet will be supported by this Berlin, and these Berlins or these secondary beams supported by the truss at this joint only. That means the final forces will be at these locations only. So we don't need to cover more details related to this point. It's outside the scope of this course, but our structure is members connected together, supported by supports, and your load only. Concentrated forces at the joint of intersection of these members. Any questions so far? Any questions so far? So please, starting from today, if you are walking around your house, if you are driving and you are watching this type of truss, so try to think, hey, yeah, we have members, these members connected together, and I believe any load on this structure will be at these locations only. And this the whole structure is supported by supports. I believe there are supports somewhere. One of them may be hinge, one of them is roller, one of them is fixed, probably. What we need, okay, we understand this interesting topic, we understand this interesting structure. What we need to figure out what is the force in this member, what is the force in this member, what is the force in this member. So your target, your final conclusion from this structure, we need to figure out what are the forces in these members. In your exam, in your homework, I will give you a truss, and I will ask you to figure out what is the internal forces in this member. Internal? Yeah, internal, because this 300 force is external, coming from something outside the building, outside the structure. So it's called external. But you are talking about force in a member, and this member is a part of the structure, so we can call it internal force. So our final target from this topic, we need to figure out what is the force in this member, what is the force in this member, what is the force in this member, what is the force in this member. Actually, every member. But in your exam, I will not ask for all of them. I will ask for few only. Okay? Sometimes your member is under tension. Sometimes it's under compression. Yeah, this whole structure probably, maybe this member is under tension. And when another member, probably this one, is under compression. So you need to figure out how much the force, and this force is tension or compression. How much the force in this member, and tell me this force is tension or compression. It's very easy. Don't worry. We need to understand the concept of this structure and how to answer. Don't worry. It will be more easy, but just follow my steps. Just a review. We have three types of support. One called fixed, one called hinge or pin, and one called roller. Okay. Fixed support, we have three reactions. 99% we will never see this type of support with truss. Probably this one is related to beam or frame. Most of the time we will find hinge or roller. Hinge, we have two reactions, one horizontal, one vertical. For roller, we have only one reaction. Just to remind you, to figure out the reactions, we have three equilibrium equations. To figure out reactions, we have three equilibrium equations. Summation f of x equals 0, summation f of y equals 0, summation moment at any point equals 0. Guys, do you remember what I told you? I told you the final target in this topic or in any problem in this topic to figure out the internal forces. What is the internal forces in this member? What is the internal forces in this member? All of these members. Actually, or unfortunately, I have bad news for some of you and good news for others. To figure out the internal force in each member, first step, you have to figure out what are the reactions value. So we need to review how to calculate reaction. The problem will ask to calculate reaction? No. Can you watch this problem? This one. The problem will ask you to determine what is the force in member AB, this one, member AE, this one, member ED, this one. My question is, did the problem ask you to calculate reaction? No, but the first step, you must calculate reaction. So, to be able to calculate the internal forces in the required member, you have to calculate reactions first. So reactions will be the first key to solve this kind of problem. So if you cannot, at this moment, if you cannot figure out how can I calculate reaction, please, you have to go back and learn how to calculate reaction. Without reactions, you cannot solve these problem in this topic, and the problems in the coming topic, and the problem in the coming topic. So reactions, I spent, if you remember, more than 1 week how to calculate reactions. Just to remind you, we have a truss. We need to figure out what are the reactions. So first step, how many supports do you have? We have pin, support. The problem will say this: pin, support at A. We have roller, support at C. Pin, support at A. That means we have vertical reaction, YA. We have horizontal reaction, XA. This A. What is the other support? Is it at E, at D, at B? No. The second support is roller support at C. So we have only one reaction. This reaction is perpendicular to this base. This base is horizontal. So your reaction will be vertical, YC. Okay, I got them. I put my reaction on the structure. What else? What is the next step? The next step, you need to apply 3 equilibrium equation. Do you remember them? Summation f of x equals 0. Summation f of x equals 0. Guys, during the exam solution, I found some student did this. Summation f of x equals 0, and they put ya plus yc minus 8 equals 0. Do you think ya and 8 and yc are in x direction? Please, when you are answering your exam, please try to protect your instructor. My health, it's not good enough to see all of these things during the grading of the exam, please. Anyway, summation f of x equals 0. So we have negative xa. We have positive 6. Do you think we have anything else? Try to think. Go ahead and watch your problem carefully. No, nothing in x direction except these two only. So, equals 0. Put your xa in one side, and everything on the other side, you will find xa equals 6. Second equilibrium equation. Summation f of y equals 0. So ya is positive. Negative 8, positive yc. I'm talking about y, vertical forces. Ya, 8, and yc, nothing else, I believe, equals 0. We have two unknowns, so I cannot do anything. Just simplify ya plus yc in one side. So I will move this one to the other side. Guys, if you move any number to the other side, please change the sign. So will be positive 8. What is the third equilibrium equation? Summation moment at any point equals 0. Do you remember? Do you remember? And I will repeat one more time. Taking a moment at any point, I have recommendation for you guys. Take moment at one of the supports. So some of you take moment at E. That's right. That's right. It's okay. Moment at D. Okay. But your problem will not be easy. Please take moment at one of the given supports. So I will take moment at E, or I will take moment at C. But I have high recommendation to take moment at the support with the highest number of reaction. Which one has more reaction? A or C? A. So I will take moment at A, and I will assume this direction is positive. Guys, it's very easy. Just listen to me and trust me. And you can watch my recorded video many times. I give you some steps, a few hints. Why you are not following me? That means you are not trusting me. Anyway, so I'm taking a moment at A, and I will assume this direction is positive. Taking a moment at A means xa times 0. We don't have distance between xa and A. Ya times 0. Keep going. 8. Guys, remember, I told you very important point. Your force and your distance must be perpendicular. So right now, 8 is vertical. This distance will be horizontal. That makes sense. So 8 times 2. YC negative. This vertical force will be multiplied by this distance, because you are taking a moment at A and you are talking about YC, so the distance in between is 4. Please don't forget we have 6 here. Positive. In the same direction, which is clockwise. Rotation about A. Can you tell me what is the distance between 6 and A? Before answering, please, your force is a horizontal force. Your distance must be vertical. Your distance must be vertical because your force 6 kilonewton is horizontal. So this horizontal force will be multiplied by this distance, which is vertical, 2. I am done. Equal 0. This term will be cancelled. This term will be cancelled. The only unknown in this equation is YC, so I can figure out the value of YC. Go back here and put YC, what is the value, so I can figure out the value of YA. Without this step, how to calculate reaction, you cannot solve this problem in this topic. Any questions so far? Thank you. Any questions so far? Okay. Guys, I would like to remind you also what is the main target in this topic, to figure out the internal forces in each member. We have members with 0 force. I can say, hey, this member has 0 force. We don't have any internal forces in this member. And I can figure them without calculation. And you can expect one of them in your exam and your homework also. How? Which member? We have a truss here. We have roller. We have hinge supporting this structure. We have some members here. The internal forces in these members are 0. Sure? Yeah, I'm sure. Without calculation. Okay, how can you figure them out? We have 2 cases. First case, joint has 3 members only. My question is, do you think this joint, how many members at this joint? 2? Forget it. How many members at this joint? 2? Forget it. How many members at this joint? 3? Probably. How many members at this joint? 1, 2, 3, 4, 5. Forget it. How many members at this joint? 1, 2, 3, 4. Forget it. We need joint with 3 members only. How many members at this joint? 1, 2, 3. Probably. How many joint? How many members? 1, 2, 3. Probably. How many members? 1, 2, 3, 4. Forget it. So we have 3 expected location. This one, or this one, or this one. Any questions so far? So first condition, in first case, look to joint with 3 members only. Only 3 members only. Second condition, 2 of them are collinear. Do you know what is the meaning of collinear? This member and this member are collinear on the same line. Can you revise your selection? Okay, go back to this joint. We have 3 members. So the first condition is good. What about the second condition? Do you think two of them, any two are collinear? No way. This one and this one and this one, everyone in a different direction. So please go back and forget this joint. So right now we have two expected location. Okay, what about this one? We have three members. That's right. This one and this one are collinear. Yeah. So this one is still working. What about this one? How many members do you have? Three? Yeah. Two of them, this one and this one are collinear. Yes, this one is still working. So right now we have two expected location. This one and this one. What about the third condition? No external forces at that joint. Wow. Do you have any external forces at this location? At H? Any given force, F1, any force? No. This one is still working. For the other one, do you have any external forces? Yes, we have P. Vertical force, P, at this location. Okay, I'm sorry. Forget it. So finally, the only joint that satisfies this one and this one and this one is this joint. That means this third member is zero. Believe me, this member has zero internal force. How many conditions? 1, 2, 3. Please search for joint with 3 members only. These 3 members, 2 of them must be collinear. And no external force at this joint. That means the third member will be zero internal force. Second case, we are looking for joint with 2 members only. Do you think this joint has 2 members only? No? 2 members? 2 members? No. 2 members? No. 2 members? Yes. 2 members? Yes. So I believe probably I didn't take a decision. Probably this one or this one. Go ahead for the second condition. No external forces at that joint. Do you have any external forces here? Like P or something like this? No. This one is still working. Do you have any external forces? No. This one is still working. So the first condition is okay. The second condition is okay. The final decision, the 2 members are zero. That means this member is zero. This member is zero. This member is zero. This member is zero. I'm talking about this member and this member at this joint, which is good for the 2 conditions. I'm talking about this member and this member at this joint, which satisfy the 2 conditions. So guys, we have some members in your truss with zero internal forces. I can figure them out without reactions, without calculations, by my mind. Just think for this case and this case, and I will repeat this information next time to cover example number 2 and example number